Hello and good afternoon, CSI 157 students. We've got a special edition video tutorial here on Packet Tracer Activity 11.4.1.2, which is the Introduction to Networks course, Chapter 11, Skills Integration Challenge. As you can see, we have our scenario over here on the right-hand side of the screen, and I've got Router 1 up here and ready to go. In fact, let's go ahead and stretch Router 1 out to give us a little more space to work with here. So basically, we're going to be doing some configuration work to Router 1, switches 1, 2, and 3, and then we've got some PCs that we'll be working with as well. So let's go ahead and dive in here. So on R1, it says configure the device name according to the addressing table. So if we go to the top here, we can see that it's simply just R1. So I'm in user exec mode. I'm going to type the enable command to get into privilege exec mode. And then I'm going to go into global config with configure terminal, and we're going to say hostname R1. Now, when we do this, we should notice over here on the right-hand side of the screen, the completion percentage has bumped up 1 to 1%. So we'll keep our eyes peeled over there to make sure that we are on target for this activity. And I should also point out that this is specifically for the Packet Tracer 11.4.1.2. This is specifically for version 5.1 of the CCNA curriculum. So this is not the version 5.0 Packet Tracer. This is Packet Tracer version 5.1. All right, so let's disable DNS lookup. So we're going to say no IP domain name and hold on just one second here. I'm expecting to see no IP domain lookup. Sorry about that. No IP domain lookup. That's what I was looking for. Not no IP domain name. All right. So we've got no IP domain lookup. And we are going to assign Cisco ENPA55 as the encrypted privilege exec mode password. So how would we do that? Well, we would say enable secret, and then this is where we would put in the unencrypted version of the password. So CISCO ENPA 55, and that is going to be our enable secret password. So it says assign Cisco CO in PA55 as the console password and the enable login. All right, so let's go down to the console. So we're going to say line con 0, and we'll say password. And it looks like it's interesting here. So the first one is Cisco ENPA, and this is Cisco, and that must be for the exec mode. And Cisco CO is console password. Okay, so we're going to say password Cisco CONPA 55, and let's go ahead. So we've got the console password and enable login. And let me see something really quick here. All right, so that should cover the console password. Require that a minimum of 10 characters be used for all passwords. So this is going to be, trying to remember here, minimum of 10 characters. And let's take a look here. It's not going to be policy. I'm trying to remember, is it under security? Security passwords min length. All right. So security passwords min length is going to be 10. And we're going to encrypt all plain text passwords. So this should be a familiar one. So we've got service password encryption. And that encrypts all plain text passwords. So create a banner that warns anyone accessing the device that unauthorized access is prohibited. Make sure you include the word warning. So we're going to say banner MOTD, and this is where we'll put a character. And so I'm just going to say warning, warning, warning. All right, and then we'll use the hash character to end the message there. So now we're going to configure all the Gigabit Internet or Gigabit Ethernet interfaces. Configure the IPv4 addresses according to your addressing scheme, and configure the IPv6 addresses according to the addressing table. So we'll come back to that actually. Let's skip here to configure SSH on R1. So I'm going to say IP domain name, and the domain name we're going to use is CCNA-lab.com. And then I'm going to say crypto key generate RSA, and then hit enter. We're going to generate an RSA key here of 1024 bits. And then we're going to configure the VTY lines for SSH access. So let's go into line VTY 0 to 15, and we're going to say transport input SSH. We're going to say transport output SSH, and use the local user profiles for authentication. So we're going to say login local. Create a user admin1 with a privilege level of 15 using the encrypted password for admin1PA55. All right, so we've got use the local user profile. So login local covers us there. Let's exit out. Now it wants us to create a user admin1 with privilege of 15, and then it says encrypted password. So we're going to say secret, and let's make sure we get the points that they're not looking for the password command. Okay, good. So that took that. All right, configure the console and VTY lines to log out after 5 minutes of inactivity. And so let's go into line, we'll say line con 0, and we're going to say exec timeout, and the timeout in minutes is 5, and then the timeout in seconds is 0. So that's going to log us out there after 5 minutes. And then I'm going to say line VTY 0 to 15, and we're going to run that exact same command, exec timeout 5 space 0. So 5 minutes and 0 seconds later, it's going to log us out. All right, block anyone for 3 minutes who fails to log in after 4 attempts within a 2-minute period. All right, and so I believe this is going to be under not login. Let me exit out here. So from global config, if I were to say login, and here we go. So login on failure. Let me make sure I get this right. Block anyone for 3 minutes. Generate syslog. Hold on. Oh, block 4, sorry. So login, block 4, so in seconds, right? So we've got 3 minutes, that's 180 seconds. And attempts, how many attempts? Failed login attempts, we said after 4 failed attempts within a time period in seconds. Block anyone for 3 minutes, so block 4, 180. Who fails login after 4 attempts within a 2-minute period. So the time period in seconds, so it would be 120 for that 2-minute period, and so that is our login block for 180, attempts for within 120. Okay. Oops, so that takes care of the block. Now we're going to go into the switch configurations. So we're going to configure the device name according to the addressing table. So let's come to switch 1 first. And actually, before we move on to the switch, let's bring the router back up here. Let's go ahead now and let's configure the Ethernet interfaces, because we've got some subnet work that we're going to have to do here. So I'll scroll back up. So on router 1, if I were to say do show IP interface brief, this is going to show me all of the interfaces. If I say do show IPv6 interface brief, this shows me the addresses currently assigned to the interfaces, the IPv6 addresses. So let's go ahead and jump into interface Gigabit Ethernet 00, and let me scroll back up here and check this out real quick. So which interface is Gigabit 00. So if I say shut, we can see that it's the interface that runs up to switch 1. So I just say no shut to bring that guy back up. All right, so the requirement that we have is the staff subnet, or the staff network there hanging off of switch 1 needs to accommodate 100 hosts. So let's talk about our subnetting a little bit here. And let me come back up to this area here. So if we have to subnet, and it looks like we're starting with the 192.168.0.0/24. So they're making it a little difficult for you because they throw that 0 there. So that's going to be part of the network, right? So this is our network ID. So I need 100 hosts here. Well, we know a /24 has a maximum available usable host count of 254. /25 has 126. A /26 is going to have 62. So we should be able to say right now that if we need 100 hosts, that is going to be the subnet that we're going to choose. Now, a /25 means the first 25 bits are set aside for network. So we say 1, 2, 3, 4, 5, 6, 7, 8 for the first octet, and then 1, 2, 3, 4, 5, 6, 7, 8 for the second octet, and then 1, 2, 3, 4, 5, 6, 7, 8 for the third octet. So right now we're at 24 bits, right? And that's our default mask for this class C address. However, we're going to borrow one of the bits, leaving me with 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8, leaving me with 7 host bits. So these are my host bits. So 2 to the 7 is equal to what? So 2 to the 1 is 2, 2 to the 2 is 4, 8, 16, 32, 64, 128, right? So 2 to the 7 is 128. Now remember, we need to subtract 2, 1 for the network ID, and then 1 for the broadcast address. So that's going to give us 126 usable. So this subnet right here, for the IPv4 information for gig 00, we're going to go ahead and use, and let me clear the screen here. And actually, we wanted to say that this was also, the subnet mask would be 255.255.255.128, right? So it's going to be 255, 255, 255, 128. That is equal to a /25. This is the CIDR notation, or the classless interdomain routing notation. And this is my subnet mask. So let me clear my screen here. So what is that subnet going to look like? Well, we're going to have 192.168.0.0.1 is going to be the first usable IP, and then .126 is going to be the last usable IP, and .127 is my broadcast address. So this will be network number 1, or I should say the network for gig 00, staff. Right? So you want to make sure that you make a note of this off to the side somewhere. And again, this is the network that we're using, 192.168.0. Again, that's my network ID, first usable, last usable, and the broadcast address. So this also tells me that the gig 01, which requires 50 hosts, and remember we looked at the different subnet masks, so 25 was 126, /26 was going to allow 62, a /27 is going to allow 30, /28 would only allow 14. So if we need 50, we know that the next network is going to be a /26 that'll allow 62 addresses. And where will it start? Well, if we've done the /25 here and we went up to 127, that would mean that I'm going to start here on gig 01 with 192.168.0.128 as my network ID. All right, so let's go ahead and configure the gig 00 interface with the information that we've already figured out here. And let's bring that up. We'll go from user exec to privileged exec, and oh boy, we need to enter this password in. I should not have spoken so long there. So the password is, where are we at here? The encrypted is Cisco CONPA55? No, sorry, Cisco ENPA55. And I guess I'm gonna actually get prompted again, aren't I? Okay, so we're good. All right, so now we're going to go to interface Gigabit Ethernet 00. I'm going to say show run, or do show run, because I want to see what the gig 00 interface looks like. So here we are. So I'm simply going to say IP address 192.168.0. And let me make sure, because sometimes they'll tell you like you have to use the first address or the last address. Accommodate 4 subnets using 192.168.0.24, 25 hosts. All right, I don't see anything that says guest network, create subnets. Okay, I don't see anything that tells me I have to use a specific address. So we're just going to keep it simple here. We'll say 192.168.0.1. And we know that our subnet mask, whoops, not 252, is 128. So 255.255.255.128. So we've got 23% completion here. Let's see. Yep, and then we jump to 26. So we're right on that one. Let's roll up a little bit here. I'm going to get the IPv6 address in here. IPv6, this is our Global Unicast address. This is globally routable on the internet as opposed to the link local address. The link local address is only significant on the link on which it's configured. So say do show run again. And there we go. We've got our IPv4 address, and make sure we're not shut down. We have our IPv4 address and both IPv6 addresses, our link local address as well as the Global Unicast. Now remember, you must have a link local address. So if you're going to put an IPv6 address on the interface, even if all you configure is the Global Unicast address, that will automatically configure a link local for you, because you don't have to have a Global Unicast address on the interface. However, you do have to have a link local address on the interface for IPv6. All right, so that takes care of gig 00. So let's pick the conversation back up here. We were talking about where we start now, so we're good here. So put a little check mark here. And we are, sorry, I was just looking here. Oh, so this is showing, okay, IP address. All right, for the subnet mask. So we're good on gig 00. So now we come to gig 01. So let's do this. Let's clear the screen. Let's make sure. I'm assuming gig 01 is going to be facing the sales network, gig 01. And I'm simply going to say shut, because I just want to confirm, right? Let's make sure that that's the interface we're working with. And then we say no shut. And we can just bring that interface back up. It's not a problem. Okay, so the task at hand, and let me make this a little thinner here in Desk Scribble. So the task at hand is now to figure out what network is going to go here on the sales side. Now, sales only needs 50 hosts, correct? So we know from the previous conversation that a /25 is going to give me 126 usable host IPs. A /26 is going to give me 62, and a /27 is going to give me 30. So if I need 50, that is going to be the sweet spot right there. And we have a little room for growth. So we're looking at a /26. And so what that means is the first 26 bits, so 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, because we have 8 and 8 and 8 and 2, and that equals 24. So now we only have 2, 3, 4, 5, 6. We have 6 host bits. And so 2 to the 6, right? So 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. However, we need to subtract 2, one for the network ID and one for our bcast, or our broadcast address. So that's going to give me 62 usable, and that is my /26. Now, the question becomes, where do we start? Well, remember, we've already used 192.168.0.0 up to .127. This was for gig 00. So I would have to start at 192.168.0.128 is my network ID. My first usable IP will be .129, and that will go all the way up to, and our block size is 64, so 128 and 64 is 192. My broadcast address will be one shy of that. It'll be 191. And so this is my Gigabit 01. So we're 192.168.0.128 all the way up to 191. So we're going to use .129 for the router interface, and let's see if router 1 likes that. So we're going to say IP address 192.168.0.129, and this is going to be 255, 255, 255. Now remember, we said the first 2 bits of the 4th octet were going to be borrowed as network bits, and that leaves us with 6 host bits, 1, 2, 3. So what is the 4th octet? We know that these guys are all used up, right, because they're 1111, 1111. But what is the value here in the subnet mask? Well, these first 2 bit values are going to be on, so that's going to be 128 plus 64, and that gives me 192. So let's try that out and see if it works. 192. All right, so we'll look at our completion percentage, and it liked it, right? It bumped it from 28 to 31. So now let's get our IPv6 address in here. So IPv6 address is going to be 2001 DB8 colon, make sure I get this, ACAD colon 1 colon 1 /64. And that is going to be the IPv6 address on this interface. Let's make sure no shut. So we'll say do show run. And there is my gig 01 configuration. Again, making sure that we have enough IP address space to go around. Okay, so let's talk about the final subnet here, which is going to be the IT subnet, where we need 25 hosts. So you can see they're really exercising you, giving you some exercise here. We had to do a /25 here, a /26 here. Now we need 25 hosts. So what do you think that's going to be? So remember, if a /25 was 126 usable, a /26 was 62 usable, a /27 is going to give us 30 usable. The 28 drops it to 14. So where are we at if we need 25? You've got it right here. So we went from a /25 to a /26 to a /27. So this means I'm borrowing 3 bits of the 4th octet. So what does that look like in terms of my subnet mask? 1, 2, 3, 4 dot 1, 2, 3, 4, 5, 6, 7, 8. 8 dot 1, 2, 3, and so now I only have 5. 1, 2, 3, 4, 5. Whoops, let me take one of those guys off. I only have 5, 1, 2, 3, 4, 5 host bits. So I've got 5 host bits. So 2 to the 5, as we already worked out, is 32 minus 2, 1 for the net ID, and 1 for my broadcast address. That's going to give me 30 usable IPs. So this matches up nicely. So for my subnet mask, I'm 255 because all of these values are on. 255, 255. Now what do we hear? Well, remember, the first value, bit position, the high order bits is 128, then 64, and then 32. So we add those together, and we get 128 and 64 is 192, and 32 is 224. All right, so let's give this a try here, and let's do it before we time our login times out at 5 minutes. So let's jump into interface, and this is going to be gig02. I always like to confirm, yes, that is gig02 there, so we say no shut. We'll bring that back up. So I'll say IP address 192.168.0. Now, here's another question. We ended, and I'll put the ending address up here, we ended this one at .127. We ended the gig01 at .191. These were the the broadcast addresses. So the network ID for the follow-on network is just plus one of these, right? So remember, this guy was gig 01 was 128. This one was 0. So now where do we start here on gig 02? You got it, at 192, which means my first usable is going to be .193. Now, remember, we're using a /27 here, so the block size is going to be 32, which means that if I added 32 to this, it would go to 225. So 224 will actually be the next network ID. And let me pull those last two guys off there. So .223 is going to be my broadcast address. So let's give that a try and let's see what happens. I'll leave that over there, and we'll say 192.168.0.193 is my first usable. And remember, the subnet mask was 255.255.255.224. We can watch our completion percentage. We should go to 37, and we do. So do show run. Let's take a look at gig 02 and see what we've got on here. And I think I just went by it. There we go. So we've got our link local. Let's go ahead and get our global unicast. So IPv6 address is going to be 2001:DB8:ACAD:2:1/64. And that takes care of our IPv4 and IPv6 address configuration. Let's see. So here is serial 000, which is not being used. Serial 001 is being used, and let's make sure we've got the right /30. 2001 FE80::1 is link local. That's correct. 2001 DB8:2::1/64, and that is correct. So here's what we're going to do on the router. We've got our IP address information entered in here. Let's save our configuration to make sure if anything goes wrong that we could get it back if we needed to. All right, now we're on to the switch config. So configure the device name according to the addressing table. And so this is pretty straightforward. Switch 1, switch 2, and switch 3. So let's get our switches up here. And we'll go from user exec to privilege exec into global config and just simply say hostname S1. And we should probably, yep, and then we just picked up a few points there. We'll do the same thing on switch 2, and we'll bring these down here now, stretch it out to give us a little more real estate with which to work. So from user exec to privilege exec into global config, hostname S2. And then let's do the same thing for switch 3. All right, so here's my CLI from user exec to privilege exec into global config. The hostname command switch 3. Got to be careful there. Switch 3. All right, so we've configured the device names. So configure the SVI interface with the IPv4 address and subnet mask according to your addressing scheme. All right, so the switch virtual interface, and let's see, do they indicate? Let me check here, basic security configuration. So the SVI, so there's no... All right, let's go back to switch 1 here. So we'll start with switch 1. And let's say do show run. And let's see what we have in here so far. So interface VLAN 1. And it's not clear. Configure the switch virtual interface. It's not clear here. And do they have any VLAN? Yeah, okay, so we are using VLAN 1. Now, a quick note on this. This is not something that you should do in production. In Packet Tracer, in a learning environment, this is okay, but just note that VLAN 1 should be shut down and should not be used as your management VLAN. You should be using another VLAN, any VLAN number other than VLAN 1 as your management VLAN. But they're asking us to use VLAN 1 here, so let's go ahead and do that. And it doesn't say which IP, so what I'm going to do is I'm simply going to say interface VLAN 1, IP address 192.168.0. So we started with .1. I'm going to go ahead and use .2 as the IP address on the switches, and let's see if it likes this. So again, switch 1 is on the gig 00 interface, and this was a /25. So the subnet mask was 255, 255, 255, 128. And yes, it definitely liked that. So we're good there on the SVI. So I'm going to configure everything for switch 1. So configure the default gateway. And this is one of my favorites. So it's IP. Whoops, sorry about that. Yeah, IP default gateway 192.168.0.1. Now this is for management traffic on the switch. And what I mean by that, it's control plane traffic. So it's traffic that would be generated by the switch. Now this is very different from what we call data plane traffic, or traffic that would be coming from the staff PC through switch 1. And that's very different. This is an example of data plane traffic. And this IP default gateway command that we're putting in here, that command is not put on this switch to route the traffic from the staff PCs. This command is put on the switch to route the traffic on, or that is generated by the switch itself. So ping traffic that goes to a different subnet than the switch has reachability to. Trace route to a network that is not a network that the switch knows about. So again, ping, trace route, this is all traffic generated by the switch, not traffic that is generated by a PC or some host out here that is coming through the switch. This command right here has no effect whatsoever on traffic from hosts on the staff subnet coming through the switch. And the best analogy that I can give you is, think about it like this. Just as the staff PC needs to have a default gateway setting for networks it's trying to reach that are not on the same subnet, so too does the switch. And so if, instead of putting in an entry like we do on the host here where it says default gateway, and this again tells the hosts, hey, if you're trying to reach a network that is not local to us, then go to this default gateway. And the switch, for the traffic that is being generated by the switch, he needs to know the exact same thing. Because when we go to ping from this switch, and I'm trying to ping the IT hosts or the sales hosts, those are not on this subnet up here. So the switch has to know how to get down here to the default gateway and then let the router route the traffic to those different networks. And so that's exactly what that command is doing for us. It's basically the same philosophy, the same theory approach that we use with the hosts. We give the hosts a default gateway, and everything that is not local to the host goes to the default gateway. And it's the same thing with the switch. For traffic generated by the switch, ping, telnet, TFTP, this is the IP default gateway statement for the switch's traffic, which is not the traffic generated by hosts that's passing through the switch. This has no effect on that. So we say IP default gateway, we give the address, and we got a bump of 2 points, so we're good there. So disable DNS lookup, so no IP domain dash lookup. So we'll add that in, and let me look back over here. So assign Cisco ENPA55 as the encrypted privilege exec mode password. So we're going to say enable secret Cisco EN, and I need to make sure I get these. They did not make this easy here on these passwords. All right, so assign Cisco CONPA 55 as the console password and enable login. So line con 0, and we're going to be using password CISCO CONPA 55. And these are definitely not easy passwords to be working with here. All right, configure the console and VTY lines to log out after 5 minutes of activity. Well, we know this command, right? Exec timeout 50. So we'll say line VTY 0 through 15. And the same thing, exec timeout 5 minutes. Okay, encrypt all plain text passwords. Again, this is a very familiar one. Service password encryption. Okay, so now we're going to go back. Let me go end, and let's say write mem. So we'll do end and write mem, and I'm actually going to do a quick test here. So if I were to ping, let's see, can I get to 64.100.0.3? And we're definitely going to be hitting our default gateway without a doubt. All right, so it looks like we may have some reachability issues that we're going to have to look into. All right, and let's see, is that the only IPv4 address out there? I think it is, so that's okay. All right, so now let's jump over to switch 2 here. And we're going to do, much the same thing here with switch 2 that we just did with switch 1. All right, so we configured the hostname according to the table. Let's configure interface VLAN 1. And this is going to be IP address 192.168.0. Now remember, we had a different range here. The first /25, and I'll write it over here, the first /25 went from .0 to .127. And then we had a /26, and then we had a /27. /26 went from .128, and again, this is the network ID, and these will be the broadcast addresses over here, right? Went from 128 to 191, and then this guy here picked up at .192, and his block size was 32, so he went to .223. So those are the networks that we're working with. Now remember, we already used the first IP in that range for the router interface. So we're going to use the second IP in the range for the switch. So that would be .130. And remember that /26 is 255.255.255.192 because we've borrowed the 25th and the 26th bit. And those are the two high order bits in that fourth octet. So we've got 128 plus 64 is 192. We should also see our percentage bump a little bit, and it did. And then let me say no shut. In fact, did I forget over here to say no shut? I think I did. All right, so if I didn't say no shut prior, let me run that ping command one more time. 64.100.0.3. And let's see if we get a different outcome here. Let me make sure that's right. See, there we go. All right, success. Okay, good. I thought we were going to have some troubleshooting ahead of us. So we've got that configured here. Let's configure the default gateway, IP and I apologize, I'm under the interface config mode here. So IP default gateway is going to be 192.168.0. What? Well, the default gateway for switch 2 isn't going to be .1, because that's not the subnet that switch 2 is sitting in. It's going to be that gig01 interface, which was part of, and I'll put that down here. So this is gig00, this was gig01, and this is gig02, right? So I'll draw a little line down here. All right, so for gig01, he sits and falls in this subnet range where 129 was the first address that was used on the router. And so that would be his IP default gateway. All right, let's disable DNS lookup. So we're going to say no IP domain dash lookup. And then here we go again with the passwords. So enable secret is going to be Cisco ENPA55. Make sure I got that right. Cisco ENPA55. And then the console password, so line con0, is going to be capital CISCO. I'm sorry, let's get the password command in there. CISCO CONPA55. All right, and we're good there. And then configure the console and VTY lines to log out. So line con0 is going to be exec timeout 50, and then line VTY 0 through 15 is going to be exec timeout. Exec timeout 50. All right, and then encrypt all plain text passwords. Service password encryption is going to encrypt all the plain text passwords. All right, so now from switch 2, let's go ahead and say write mem, and let's give it a go here. Ping 64.100.0.3. We're probably going to have to ARP, right? And then take a look at that. We've got success from switch number 2. All right, over to switch number 3. So let's go from user exec to privilege exec into global config. And we've got the device name, so interface VLAN 1. And we're going to say IP address 192.168.0. Now we need to be careful. Remember, switch 3, who is here, sits on that network. And this is gig02. And so we know that gig02 ties in with what's going on over here. The first IP that was used, right, the first usable was .193. So for the switch, let's just go ahead and +1. Oh, and I did not want to do that. Let me see if I can undo that. Okay, there we go. Yeah, I did not want to erase that on you. Sorry about that. So let's go ahead and say 192.168.0. And we'll use 194 as the IP address. And let's put our subnet mask in here of 255.255.255. Now remember, this is /27. The first 3 high order bits are being used here. So it's 128 and 64 is 192 plus 32 is 224. All right. So that takes, and then definitely let's get the no shut in there. That definitely takes care of the SVI, the IPv4 addresses according to the scheme. All right, configure the default gateway. So I'm going to exit out. I'm going to say IP default gateway. And so my default gateway is that first usable IP that I assigned to the router interface, 192.168.0.193. And we should see our completion percentage bump up a little bit there to 69. Okay, perfect. Let's configure, or I'm sorry, disable DNS lookup. So no IP domain lookup. So we disabled the DNS lookup. Let's assign the enable secret of CISCO ENPA55. And then to the line con0, we're going to say password CISCO NPA55. Configure the console and VTY lines. That's right. So we'll say exec timeout 50, and then line VTY to grab all the console lines 0 through 15. Exec timeout 50, and encrypt all plain text passwords. So we've got service password encryption. Now you'll notice over here the completion percentage, this only takes us to 73. So we've clearly got some other things that we need to work on here. And I'm assuming that the hosts need to be addressed as well, because the first one we looked at didn't have any addressing information on there. The basic security interface configuration runner. Furthermore, configure the SPI's basic security and the switches. Okay. So we created the subnet. So let's go ahead. Let's IP up the PCs here. You'll see it says static, right? So we better put an IP address in here. So for the staff host, we're just going to use 192.168.0. We already used 168.0. We already used .1 and .2. So I'm just going to simply use .3. Sorry about that. .3. My subnet mask, it puts in that default there, but that's not what we want. We want 128. And what is my default gateway? Well, it's 192.168.0.1. All right, so everything looks good there. Static IPv6 address. It's got the link local here. And is it asking us to assign? I guess we'll go ahead and let's put the IPv6 on here. DB8 colon ACAD colon I guess we'll just use 2. And we'll put /64. So I guess we'll go ahead and use that. The IPv6 gateway, I guess we're going to use, we should use FE80 colon 1. Yeah, so we'll use the FE80 colon 1. All right, so we'll close that down. Let's pull this, oops, sorry, not that terminal. Let's pull the command prompt up, and let's give it a go here. So ping 64.100.0.3. All right, that looks great, yeah? So we've got connectivity from the PC all the way out to, who are we pinging? What is that? That's the web server address. Now let's give it a try with IPv6. So I'm going to say 2001 DB8 colon ACAD, I'm sorry, the web is cafe, CAFE colon 3. And there we go. We've got full IPv4 and IPv6 connectivity from PC1. Let me now pull up, I think it wants us to pull the web browser up here. So let's pull the web browser up and let's say www.cisco.pka. And I'll click go and take a look at that. Small page, some copyright information. Cisco is always good about getting their copyright information in there. Here's the Cisco logo, right? So that's working great for us. Now let's check our IPv6 web access, www.cisco6.pka. And I click go. And I believe that this is going to take us here. Are we looking at, maybe we're hitting the same page. I don't know. There's no refresh. So yeah, so it looks like we're good, right? Same information, but everything looks good here. So we've confirmed from PC1 that everything looks great. Let's hit the sales PC up here. And let's come over to the desktop and let's go to the IP configuration. So the sales PC is going to be 192.168.0. Now what are we going to use here? Now remember the sales PC, and let me change colors up here. The sales PC sits on that subnet. And remember that that subnet is for Gigabit 01. So if we come over here, we see Gig 01, that fell in the 128 to 191 range. We've already used 2 of those addresses. We use 129 for the default gateway. We use 130 for the switch. So, and that is not going to work. We use 130 for the switch, so let's go ahead and say 192.168.0.131 for the PC with a subnet mask of 255.255.255. Now this is a /26, so the first bit is not just the first bit is borrowed, the first 2 bits are borrowed, so that's going to be 192. My default gateway 192.168.0. And that was the first address we used on the router that we assigned to the Gig 01 interface on the router, because the router is my default gateway. He is my path off the local segment. and that was 129. Let's get our IPv6 address in here on gig01 was 2001 db8 colon ACAD colon 1 colon. We already used .1. Let's use .2, make it a /64, and FE80 colon 1 as my default gateway. So everything looks good there. Let's test connectivity, v4 and v6. So I'm going to say ping 64.100.0.3, and take a look at that. We've got full IPv4 reachability from the sales subnet host out to that web server. Let's check our IPv6, 2001 db8 colon cafe colon 3. IPv6 is also working beautifully. Let's check our web browser. So we'll say www.cisco.pka. All right, that works great. Let me put Cisco 6 in here and click go, and let's see. Yep, and the Cisco 6 works. Although, okay, there we go. I was waiting for the copyright to load. And then the image page. So we've got full connectivity from PC2 as well. Let me check something on PC1 real quick. I want to make sure I put in, okay, good, 128. Just checking my subnet there. All right, so last but not least is the IT subnet for the IT host. We'll go to the desktop. Let's get the config up here. So we know this is going to be 192.168.0.what. So remember, this IT host, what subnet is he on? I did says, oh, actually, yeah, so we already did gig 02, so let me switch back to red here. There we go. So he's on gig 02, the IT host. And gig 02 corresponds to this guy right here, where we started at 192. We used 193 for the router interface for router 1. We used 194 for switch 3. So we'll just use .195 for the PC. All right, let's come back over here. So, oops, get that invalid address, caught us again. All right, so here we go. So we're going to say 192.168.168.0. and we're going to use 195. Our subnet mask is definitely going to change, right? Because we have a subnet mask of 255.255.255 dot, and it's a /27, so the first 3 bits are being used. So 128 plus 64 is 192, plus 32 is 224. So we get our subnet mask in there. Our default gateway is going to be 192.168.0 dot, the first IP that we assign to that gig 02 interface to get me to that router 193. And then we'll come down here to the IPv6 address, and this is going to be 2001 db8 and boy, we've got all kinds of writing on top of it there. 2001 db ACAD 2 Now we've already used 1, so we'll just use 2 here. It's a /64, and FE80 1 is going to be my default gateway. So now let's check connectivity here. Let's go to the command prompt where we're going to say ping 64.100.0.3. So IPv4 connectivity is there. Ping 2001 db8 cafe 3. And we've got connectivity there. Everything looks great. So IP connectivity all the way through. Last check, www.cisco.pka. And there it is. Let's take a look at the copyright. We'll take a look at the small page with Hello World. I'll put Cisco and the number 6. Put the number 6 in there, and then we'll take a look at the image page with Cisco 6. And we'll give it a second. There's the image. We'll say back. There's just the image by itself, and you can see that up here we still say Cisco 6, so we're good. So we've now validated connectivity all the way through. We've done everything, and we are at 98%. So let me do this. Let's bring that up. Let's clear the screen, and then let's come down and let's check our results. Let's see what it is they want us to do in addition to the tasks we've done. So we overlooked something that would cause 2 points. Oh, come on. It was the password? All right, password on the console line for switch 3. It was right on switch 1 and 2. All right, so we missed that. So let's go back. I probably typoed it. Let's check it out. So we'll slide this over here. Let's bring switch 3 back up, and let's... Not that. And I don't know why it's doing that. Let's bring switch 3 back up here, and we're going to go from user exec to privilege exec, and we get the privilege of entering in the not so easy to remember password here, which is on the switches CISCO ENPA 55. So now we're into privilege exec mode. So I'm going to go into global config mode, and let's say do show run. Let's see, did we forget the password? Well, we've got a password here, but it said it did not like that password. So I probably typoed the password. So let's go ahead and say linecon 0 password, and the unencrypted password should be CISCO CONPA 55. And there we go. So I must have typoed that password. All right, well, this has been the version 5.1 CCNA curriculum packet tracer tutorial for packet tracer activity 11.4.1.2. Boy, we had quite a bit of work to do, some heavy lifting here on router 1, as well as over on the switches. The key things that would have caught us: configuring the PCs properly for IPv4 and IPv6, the subnetting that we would have come up with for each of our different subnets for the staff, the sales, and the IT department. And real quickly, the reason, and it makes total sense now, the reason that they make this comment in here that says the subnet for the rest of the staff requires 100 hosts. And there's a very specific reason that they put that statement in there. Because you can see the IT department needs 25. Or I'm sorry, not that statement. There was another one. Yeah, the guest one here. So let's clear that. So this statement right here, guest subnet will be added in the future to accommodate 25 hosts, right? So the reason that this is here, this is a very important point with respect to you configuring the subnets, because what they didn't want you to do was make this, right? So we used this one here was 192.168.0.0 up to .127. Then we said, so we used a /25 here. Then we used a /26 here for the 50 host, and that said we're going to go from 192.168.0.128. Remember, the network ID first, to, and our block size with that /26 was 64. This went all the way up to .191. And then finally down here we had the /27, which would have run from 192.168, and actually let me back that up because I'm getting ready to run into the web server here. 192.168.0.192, and hold on, I don't like the look of that. Let me double check this. 128.64. Yeah, okay, so we're right. So 192 up to .223. So now the next network is going to start at 224. Now remember, we only go up to 255, right? So when we're already at 224, this only leaves what? What is the last largest subnet that we could use for these 25 hosts that they're talking about? Well, it would have to be a /27, or at least that's the largest one that we could use, and it would start at 224. The block size is 32, so it would go up to .255, and our usables would be .225 all the way up to .254. Now that is the last subnet that would be available after we did all of this work right here. And it would meet this requirement. The reason they put that there is what they wanted to make sure you didn't do was say, oh, well, I'll use a /25 here, a /26 here, and a /26 again. Do you see that? Because if you don't do a 25, a 26, and a 27, you are not going to have a subnet left over for the guests that will be able to accommodate 25 hosts. Because if this last one here was a /26, we would have started at 192 and it would have gone up to what? The block size at that point is 64. The last address would have been .255. We would have been out of addresses. Because out of the /24 that we're using, we can get 2 /25s or 1 /25 and 2 26s. Right? But that would have meant that this guy would have never happened. So it has to be a 25, a 26, and a 27 so that it leaves over one more 27 to hold us up for these 25 hosts for the guest subnet. All right, and you can see here where they put the little bullet point as well that that's going to get added on later on. All right, well, I hope this has helped you out. I hope you've got a much better understanding of subnetting, how to come up with your own subnets. We haven't got a whole lot into IPv6. Again, this is the first Networking Academy course, and this is definitely one of the more challenging skills integration challenges that's out there. I thank you for watching, and enjoy the rest of your weekend.